Okay, so we're going to do these three CYU problems. This is CYU 18, so we'll do lesson 18, 19, and 20. So here we're going to convert the density of ice, which is 916.7 kilograms per meter cubed, into pounds per gallon. And we have some conversions we're going to use. 1 kilogram is 2.2 pounds, and 1 cubic meter, that's 1 meter to the third power, which is a measurement of volume, is 264 gallons. Okay, so let's put this up on our screen this way. Oops, I got it here somewhere. Put all the information down there. So we're going to start with what we know, which is 916.7 kilograms per meter cubed, and we want to get to pounds per gallon, lbs per gallon. This is typical of a test question too, by the way. So you got to understand that that's 1 meter cubed, right? You know, when they just say, like, if you pay $3.20 per gallon of gasoline, you know that's 1 gallon. Same type of idea here. So you could change either meters cubed to gallons or kilograms to pounds first. It doesn't make any difference. Let's get rid of the meters cubed. So meters cubed is going to go on the top so that they cancel, and gallons on the bottom, so they cancel. So now we have kilograms per gallon, or per 264 gallons. Now we want to get rid of the kilograms, so that's in the numerator, so we're going to put it in the denominator and put up the conversion. 2.2 pounds per 1 kilogram. Kilograms cancel, and we now have the units the way we want it, in pounds per gallon. So you just got to do the math. Calculator, I'm going to go 216.7 times 2.2 divided by 264. And I get 1.81 pounds per gallon. So I don't know how, watch it, I don't know how they want the rounding, but that's what the answer is. Alright, that's the first one. Okay, so in this one, we're saying a medicine comes, this is how it comes, 390 milligrams at 200 milliliters. So this is like the particles in the solution. Think of it as salt in salt water. Here's the salt, here's the salt water. So when they get the medicine, this is how it comes, right? So the doctor ordered an infusion of a dosage of 25 milligrams, that's 25 of the particles of the medicine, for every kilogram that they weigh. That's what this means. And the patient weighs 225. So they want to know how many milliliters to administer. So I got it here, basically, kind of stuff there. This is how the medicine comes. This is the prescription. This is the person's weight. So they want to know how many milliliters do they need to take in order to get this exact dose. Their weight's important because you're prescribing 95 milligrams for every 1 kilogram of body weight. So the first thing I'm going to do is take this 225 pounds and change it into kilograms using this conversion, right? So basically we're just dividing. and that'll give us the kilograms. So it's 225 divided by 2.2. So it's 102.3. I'm just going to round it to 102, or I'll make it 102.3 kilograms. Alright, so I gotta know, before I know how much to give over here, I gotta know how much I need to give, right? So if it's 95 milligrams for every kilogram, and this person weighs 102.3 kilograms, hope you can see I could just multiply 95 times 103, right? I mean, I don't think you could also do this. If you need to. So if you multiply this by 102.1 times 102.3 is 102.3, so 95 times 102.3 is how many milligrams you're going to need to administer to this person. And you can see it's, and I'll do that on my calculator. 95 times 102.3, and that is 9718.5, and that's milligrams. And the way the math works out here, if you just do it, that's 95, you want 95, the units I'm talking about, milligrams per 1 kilogram times 102.3 kilograms. You can see the kilograms cancel and you're left with milligrams. So that's another way to look at it. So now it's just taking, okay, here's my dose. It's 390 per 200. So you get 390 milligrams for every 200 milliliters. So therefore, if I need 9718.5 milligrams, how many milliliters do I need to administer? So this is just a simple cross multiply and divide. 200 times 9718.5 divided by 390, right? Hopefully by now you can follow that. So it's 200 times 9718.5 divided by 390, and it's 4983.8. 4983.8 milliliters, which may seem like a whole lot, but it's actually it is a lot, but it's about what is that, about 4 liters, just over 3 quarts. Okay, so we're doing the last one on this. It says convert 33 square meters to square feet. And here's what they give you. 1 yard is 0.9 meters. I'm just writing this down. And 1 yard is also 3 feet. Okay, so let's go to our live screen here. And there's why I wrote it down. Now, we're starting out with 33 meters squared. And we want to end up with feet squared. So we can turn meters into yards, and we can turn yards into feet. But you got to be careful here, because let me write this down. 1 yard is 0.9 meters. Now the problem is that meter squared, this is area, right? area like this, right? Like a box is area, where this is just length. So there is a relationship between length, square, and volume, right? So the first power to the second power to the third power. So what I'm going to do here is take 1 yard over 0.9 meters, and I'm going to square the whole thing. 1 times 1 is 1, so 1 yard squared is the same thing as 0.9 times 0.9, which I believe is just 0.81. I should know that, and it is 0.81 meters squared. So there's the conversion you need to use here. So, and then the other conversion is going to be, yeah, once you get the meters squared cancels, you got to turn yards into feet squared, right? So here we have, well, let's just make this, write it out the way we got it. Right now we have 33 meters squared times, that's in the numerator, so we want the denominator 1 yard squared over 0.81 meters squared. So these cancel. So now we have whatever we have, and we have square yards. But the only thing we know is you put the yards on the bottom and the feet on the top. We know that there's 3 feet in 1 yard. But I can't cancel this, yards and yards squared. So I have to do the same thing I did below. I'm going to go 3 feet is the same as 1 yard. So I'm going to square the entire numerator and square the entire denominator. So here I'll get 9 feet squared over 1 yard squared. So 1 square yard is the same as 9 square feet. So I'm going to change this here to 9 feet squared over 1 yard squared. And the yard squares cancel. And now I have to take 33 times 9 divided by 0.81. Do that on our calculator. 33 times 9 divided by 0.81. And I'm going to get 366.7. 366.7 feet squared is the same as 33 meters squared. So I'm converting square area to square area. Okay, this is 19 CYU. You've got a GPA of 2.4 after 38 credit hours, which is, I don't know, a little more than a full year, full time. And this semester you're taking 14 credit hours, and your GPA for this semester is a 3.8, which is a minus, B plus. What would your overall grade point be after this semester? So you gotta, this is a weighted average. So let's look at it this way. Here's the data, right? This is how you always work a weighted average. You might want to write this down on your 3x5 note card too. It's the weight times the data plus the weight times the data plus the weight times the data, however much you have, divided by the sum of the weights. So this one's going to be 38 times 2.4 weight times the data plus the weight, which is 14 times 3.8 over the sum of the weights. And the sum of the weights are here, which is 52. and I'll go over, the only mistake students usually will make sometimes is confuse the sum of the weights with the data. So they might do this: 38 times 2.4 plus 14 times 3.8 divided by, and they might put down here, add these two, which would be 6.2. Let's see what we get. Now it should be obvious that our answer is going to be greater than 2.4, but less than 3.8, and a little bit more towards 2.4 because there's more weight coming here, right? So let's do the first one here. 38 times 2.4 plus 14 times 3.8, and I got 144.4. And now I'm going to divide that by 52, right, which is the sum of the weights. And I get 2.78 GPA, which makes sense. You know, if you think about it, makes good sense. It's got to be somewhere between here and here. So this is correct. But if you messed up and you got the weights wrong, let's do that one. 38 times 2.4 plus 14 times 3.8 equals, of course, 144.4 divided by 6.2, and I get 23.3. Which is ridiculous. The highest grade point is 4.0, or something like 4.1 maybe in high school. Certainly there's no such thing as that. So if you do this and you get a bizarre answer, most likely it's because you've confused the weights and the data. This is clearly the weights, right? Because they change, and this is what's determining how far you go towards one way or the other with the data. Alright, for our number 20, which is our last CYU problem, it says, what do you multiply a number by in order to increase it by 7.5%? And that's called a factor. That's what you multiply it by. And to decrease a number by 5.8%, you multiply it by what number? Right? And then it says anytime you want to increase a number by a percentage, the factor you multiply will be greater than 1. And anytime you want to decrease a number, right? If you multiply a number by 1, it doesn't change. If you multiply a number by greater than 1, it gets bigger. You want to increase. You want to decrease, you got to multiply it by a number less than 1. Well, let's look at this specific problem here. This is the key idea here, a little sloppy, of course, everything is. 1 plus or minus r. If you want to increase a number, it's 1 plus the percentage. If you want to decrease a number, it's 1 minus the percentage. The percentage, of course, has a decimal. So if you want to increase by 7.5%, you go 1 plus 7.5 over 100, because that's what 7.5% means. If you want to be fancy and multiply by 0.07, add 0.075, that's fine. If you know how to move the decimal and get away with it. So 1 plus r, which is 7.5 divided by 100. So you'd multiply by 1.075. That's the factor. So if you take a number and multiply it by 1.075, that is increasing it by 7.5%. Now, if you want to decrease it by 5.8%, it's 1 minus R. So it'd be 1 minus 5.8 over 100. And if you want to be fancy, you could just do 1 minus 0.058. Because that's the decimal equivalent of the percentage, right? A percent means over 100, and that's the decimal equivalent. So let's put that in our calculator. We got 1 minus 0.058, and I get 0.942. So that means if you multiply a number by 0.942, what that does to the number is decrease it by 5.8%. This is a really important concept that you get. 1 plus or minus R. That's how you go from here to here. From what you're trying to accomplish to the factor to accomplish it.